The role of space in advancing high-speed data transmission is a testament to the transformative power of space technologies in reshaping communication on a global scale. As our world becomes increasingly interconnected, the demand for high-speed, reliable, and ubiquitous data transmission has never been greater. Space-based systems, leveraging the vastness of the cosmos, have emerged as pivotal enablers of this digital revolution, pushing the boundaries of what's possible in data communication technologies. One of the cornerstone technologies enabling this leap in data transmission capabilities is satellite communication. Satellites, stationed in various orbits around Earth, facilitate a wide range of communication services, from television broadcasting to internet access, particularly in remote or underserved areas where traditional, terrestrial infrastructure is not viable. The advent of high-throughput satellites, HTS, has dramatically increased the capacity and efficiency of satellite communication systems. HTS utilize spot beam technology, which focuses bandwidth over specific areas, allowing for the reuse of frequencies and significantly boosting data transmission rates. This has paved the way for satellite internet services that can compete with terrestrial broadband in both speed and reliability, making high-speed internet access more accessible worldwide. Moreover, the development of mega-constellations, large networks of satellites in low Earth orbit, LEO, promises to revolutionize global internet coverage. Companies like SpaceX, with its Starlink project, and OneWeb are deploying thousands of small satellites designed to provide low-latency, high-speed internet across the globe. These LEO satellites, closer to Earth compared to their geostationary counterparts, can reduce signal delay, enhancing the performance of real-time applications and services. The deployment of these mega-constellations is a game-changer for rural and remote regions, bridging the digital divide and fostering global connectivity. Beyond communication satellites, space technologies play a critical role in the development of optical communication, or laser communication, which offers a quantum leap in data transmission capabilities. Laser communication systems use light to transmit data, allowing for much higher bandwidths and data rates than traditional radio frequency, RF, systems. The potential of laser communication has been demonstrated in various space missions, such as NASA's Lunar Laser Communication Demonstration, LLCD, which achieved unprecedented data download rates from lunar orbit to Earth. The European Space Agency's European Data Relay System, EDRS, also known as the Space Data Highway, uses laser communication to relay information between satellites, drones, and ground stations in near real time, showcasing the potential for laser communication in enhancing Earth observation capabilities and crisis management. The integration of space-based data transmission systems with terrestrial networks is another critical aspect of advancing high-speed communication. Satellite ground stations, strategically located around the globe, serve as the link between space and Earth, receiving and transmitting data to and from satellites. The development of more efficient ground station networks, along with advancements in antenna technology and signal processing, is crucial for maximizing the throughput and reducing the latency of satellite communication systems. Looking to the future, the role of space in high-speed data transmission is set to expand with the advent of quantum communication. Quantum satellite systems, such as China's MISHUS, are exploring the use of quantum entanglement for secure, ultra-fast communication across vast distances. Although in its nascent stages, quantum communication holds the promise of revolutionizing data security and transmission speed, potentially leading to a new era of communication technology. In conclusion, space plays an indispensable role in advancing high-speed data transmission, driving innovation in satellite communication, optical communication, and potentially quantum communication. These space-based systems not only enhance global connectivity and communication capabilities but also lay the groundwork for future technological advancements. As we continue to explore and utilize space, the possibilities for high-speed data transmission and its impact on society are boundless, heralding a new chapter in the digital age.